back at AP Review. This is BC Free Response 5 from 2018. So we're given a polar curve. The first thing I want to point out is that this is problem 5, so it's a non-calculator problem. So them giving you the curve was doing you a massive solid, because the last thing you want to do when you're already bogged down with lots of calc is have to sketch a polar curve. So that was nice of them. They then do you another solid too. They tell you the points of intersection of the two curves. So the one curve is r equals 4, and just like in regular math, if a radius is constant, we're talking about a circle. So the red thing I drew here is your r is 4. And then this blue thing I drew here is the other slightly more complicated curve, the r equals 3 plus 2 cosine theta. If you're ever not sure which is which, you could also plug in some really easy thetas, like the zeros and the pi over 2s and the pi's, to see which curve is which. But that's which curve is which. And then there's this shaded region here, and then they do us this awesome solid of telling you that the curves intersect at pi over 3 and 5 pi over 3, which you could have figured out. It's not that hard to solve, but thank you, calculus test, for doing us a solid. Okay, so part A. Let R be the region that's shaded here, right? I didn't label it as R in my diagram, but hey, that's R, right? Big R. It is inside the graph of r equals 4, the circle, but outside the graph of r equals 3 plus 2 cosine theta, as shown in the figure above. Write an expression involving an integral for the area of r. So this is really just testing your understanding of integrals, like if you understand the way that that polar curves work, like if you know the definition of this formula. So the area inside any old general polar curve is 1/2 the integral from the starting theta to the ending theta, r squared d theta, right? But when you have two curves, essentially you're taking the area inside the circular curve from pi over 3 to 5 pi over 3, which would be like this Pac-Man-y area, right? Like this thing to this thing, which would kind of look like a Pac-Man. And then you're subtracting this little void of area that we don't want, which would be the same formula, the same area formula for the blue curve, for the other r. So they specifically said using a single integral. So technically it's the integral of this whole thing minus the integral of the little void thing. But the easier way to write it is to say 1/2 the integral from the starting theta, which is pi over 3, because numerically that comes before 5 pi over 3, of the big R, which would be 4 squared, minus the little r, which is 3 plus 2 cosine of theta quantity squared with respect to theta, right? And you shouldn't simplify it. There's no reason to do that. You do need these parentheses here. You don't have to call 4 squared to 16. No incentive to do it. Leave it alone. Perfect. So that's your answer to A. They really just wanted to know if you understood the formula for how to find area in polar. Part B. Find the slope of the line tangent to the graph for r equals 3 plus 2 cosine theta at pi over 2. So at this spot right here, what's the slope of the tangent line? So forever and always in the rest of math, slope is always change in y over change in x. So in order to find my slope, right, I need to find the x and y terms, right? So slope, right, when we go to do part B, right, slope is always change in y over change in x. So what I need to do is I need to use the formula we know to convert between polar and rectangular coordinates, which is really just converting between polar and rectangular coordinates is really just using SOHCAHTOA, right? So cosine of this theta would be x on top of r. So x equals r cosine theta, right? And y is, the sine of theta would be y on top of r, so y is r sine theta, right? So I get that x is r, which is this ugly monstrosity, 2 cosine theta times cosine theta. And y is 3 plus 2 cosine theta times sine theta, right? So when I go to do my x prime on top of my y prime, right, I need to derive, there's a couple different ways you can do this. One way that you'll sometimes see people do this is they'll find dr in advance, and that's one of the things that the AP chose to do because it can make your life a little bit easier. So when you derive this, it's going to be a product rule. So one way you will sometimes see people do this is they will look and they'll say, hey, ahead of time, let me find dr. So we want dy dx, but it's not a terrible idea to say, hey, wait a sec, I know that r of theta or is this 3 plus 2 cosine theta, right? So r prime of theta, right, my r prime, is going to be a negative 2 sine theta. And that's not a terrible idea because then when you do your product rule, it's a little bit easier. So it's not wrong if you have this as your x and y, but if you just use r and cosine theta, then my dx dt, right, sorry, not dt, d theta, my dx d theta, or my x prime of theta, right, is going to be u, which is the r, so r, right, dv, which will be the derivative of cosine, which is a negative sign, plus v, which is the cosine, du, well, I already bothered to find what the derivative of r is, so I could just write that as a negative sign, theta, right? And my dy d theta is going to be the same basic policy, except instead of deriving a cosine, I'm deriving a sine. So u dv is a cosine, right? Plus v, which is the sine. Du is that same negative 2 sine theta that we've already seen, right? So in order to find the slope at this point, right, so when we go back to b, what they want, right, so what b wants is dy dx evaluated when theta is pi over 2, right? Theta is pi over 2. Well, in order to do that, I'm going to do dy d theta, right? So it's going to be dy d theta evaluated at pi over 2 over dx d theta evaluated at pi over 2, right? And I can do that. The nice thing about pi over 2s is that anybody that has a cosine is going to get knocked right out, right? So this is going to be 3 plus 0, so that's just a 3, times a negative 1. Oh, sorry, I put that on the, hang on, tragic brain. That was my dx d theta, sorry. Start with my dy d theta. So this is a 3 plus 0 times a 0, so that's all knocked out, right? Plus a 1 times a negative 2 times a 1. Cool, we'll deal with that in a sec. And on the bottom, I should get 3 plus 0 all times a negative 1, plus stuff that's going to get wiped out as a bunch of 0. So it seems to me that when all is said and done, the only thing that I have left, sorry, we'll squish over there, should be a negative 2 on the top and a negative 3 on the bottom. So my slope should be 2/3. So that's my tangent slope. Right, my tangent slope is 2/3. And there are other ways to get there and do that, but that's the gist. They only wanted the slope. They did not want the point or the equation. Great. Okay, lastly, C, a particle moves along the curve r equals 3 plus 2 cosine theta from 0 to pi over 2, so only in quadrant 1, which I was going to point out on my graph, but my graph's not there anymore. In such a way that the distance between the particle and the origin increases at a constant rate of 3 units per second. Find the rate at which the angle theta changes with respect to time at the instant when the position of the particle corresponds to theta equals pi over 3. Okay, let's go back and reread that because that was very long and I'm sure I did something stupid. Okay. So, now we have some space to work. Okay, one more time. All right, a particle moves along this curve, right? Such a way that the distance between the particle and the origin increases at a constant rate of 3 units per second. Cool. All right, so we know, okay, so what they just gave us in part C, so the distance between a particle and the origin when it's moving along a curve, right, so like it's on some curve. I'm doing a terrible job of drawing that curve, but whatever. So we're only talking about this window. We're talking about 0 to pi over 2, so we don't care about all this. And what we're saying is its distance, right, from the origin to the point on the curve, well, that's just r, right? So that's r. They're saying that the distance is changing, dr dt, at a constant rate. The reason it's dt is because with respect to time, not theta, at a constant rate of 3 units per second, right? So 3 units per second, and it's increasing, so 3 is positive. Sorry, that's my dog dreaming in the background, and he definitely kicked the door. Yeah, he's still dreaming. Hold on. Hey, buddy, come away from the door. Good boy. Okay. All right, so, what we know is that so this is a related rates problem, right? So that's what we're talking about. We're talking about a related rates problem because what they want is they want to find the rate at which the angle, so they want us to find d theta dt, the rate at which the angle is changing with respect to time, when the position of the particle corresponds to theta equals pi over 3. So when theta is pi over 3. Right, so when we do related rates, we do dread saw, right? We have a diagram and we label rates, which we already did. We need an equation. Well, we already have an equation that relates r's and thetas because we know that r is 3 plus 2 cosine theta. Then we derive with respect to time, right? So dr dt equals, the 3 will go away. I get a negative 2 sine of theta d theta dt, right? And this is the thing I want to find. I want to find it at the moment when theta is pi over 3, and I know dr dt. So when I substitute in, 3 equals negative 2 times the sine of pi over 3 times d theta dt. So this is a 3 equals negative 2 times a root 3 over 2, so they'll get canceled. So when I divide by the negative root 3, I should get the d theta dt is a 3 divided by negative root 3, and you can rationalize that if you want. That's fine, because theta is measured in radians and time's measured in seconds. We're talking radians per second. This is a totally okay answer. If you want to rationalize it, it's a negative root 3 radians per second. So the trick here is that you really have to read it carefully, and if you're not reading carefully, it's easy to miss, but this was a fairly run-of-the-mill related rates problem that didn't have a whole lot to do with polar, aside from the fact that the equation they gave you was polar.